Hi everyone, my name is Ali Al-Shabibi and this is my colleague Jonathan Hart. Today I'm going to be talking to you about CORD, Central Office Re-Architect as a Data Center. This is a project that we've done in partnership with Scipio, PMC, ONOS Project, AT&T, ON Lab, and Akamai. So what's the problem here? We have large central offices which have been evolved over 40 to 50 years, and they're extremely complicated. They contain a lot of complicated pieces of hardware that have to be deployed and maintained in a specific way. And each one of those have their own maintenance cycles. That leads to a huge source of CapEx and OpEx. So we're introducing a new architecture for the central office. And in this new architecture, we have a leaf-spine fabric controlled by ONOS. Then we have an NFV orchestration system called XOS. And XOS orchestrates all the applications that run in your now data center. And then we have access connectivity into the home or the enterprise. We have an OLT MAC and a G.Fast. Both of these are disaggregated in the sense that they are now controlled by OpenFlow, and we can provision rules onto them when the subscriber comes up. So that was the architecture of the demo. Now we're going to show you what we have actually set up in the demo. We have a white box home customer premises equipment, which is a Netgear flash with OpenWRT. It doesn't run any other software other than authentication. We have then a GPON OLT and a Scipio G.Fast. And the OLT is disaggregated, and we have a VOLT application which is controlled by OpenFlow. And that allows us to provision rules as soon as this guy comes up. Then we have a virtual CPE, which is the CPE for the white box. And then we have a VBNG, which connects the subscriber to the internet. So when the home premises equipment comes up, it authenticates against the system, and we authenticate against Radius. And from Radius, we get all the information. That allows us to provision the network for the subscriber. So for example, we get what kind of services he's subscribed to. Does he have IPTV? Does he have internet connectivity? And what other services? And we provision the network for that. Here we have a leaf-spine fabric controlled again by ONOS. And all the applications that you see here virtualized all have a counterpart on top of ONOS. So now we're going to move to the actual demo. And the demo is made up of three parts. It's a subscriber part, and a service provider part, and a third-party content provider. And we're going to show you each one of those in succession. So let's start with the subscriber. So in the subscriber demo, it's from the point of view of a home network, and from the point of view of a family where there's dad, mom, Jack in jail. Dad is annoyed because Jack is spending all his time on Facebook, and dad wants to change this. So Jack is on Facebook, and he is surfing around, not doing his homework. So dad logs into the subscriber portal, and when he logs in, he sees the users in his home network. And here he has again a user list, but no parental control. So he decides that this is the time he's gonna buy the parental controls. So he goes down and checks out his available bundles and sees that he's got a family bundle. He applies it, and now he's got parental control. When he goes back to the user list, he sees that he's got a new column with all parental filters set up. And then we have here where he says, I want to block social networking, so he has to select the PG settings, so he can go and select PG for Jack and applies it. At this point, Jack should be filtered and can no longer access Facebook. So now Facebook is blocked. And he can no longer access Facebook, and Jack has to go back and do his homework, and dad is happy. The second part of the demo is from the point of view of a content provider. This enables a third-party content provider to cache content in CORD and serve it with a better quality of experience to his customers in the home. So we've already preloaded several caches and several prefixes in our system. And we're going to show you that if you try to download content from outside the cache network, you're doing so at a very, very low rate. But whereas if you do it, so you can see that here there's only a few kilobits per second, it's really slow. If you go to the CORD network and you download it, and you download from the CORD network, you'll see that it goes very, very fast because we've cached the content in the central office, and we can see that it downloads super fast, while the other one has barely started, we're already done. That's great. That's what we want. So we show that a content provider is now capable of caching content closer to his customers and deliver either movies or other content quicker to his customers. Finally, we're going to show you the last part of our demo, which is from the point of view of an operator. And so this is the operator that manages the infrastructure, who is tech savvy and understands what's going on with his infrastructure. So if we log in, we see that there are multiple services running: VoLT, VCPE, VBNG, and HyperCache. So if we check out VCPE, we see that there are many virtual CPEs running, and this is quite a complicated view that an operator would understand, but it's kind of complicated to explain out here, so we're going to explain it on a set of slides. So we have a set of virtual CPEs integrated by a private virtual network, and each of these VCPEs is connected to multiple other virtual networks. On one side, we have VCPE LAN, which connects the subscriber connects the VCPE to the subscriber network. We have the VCPE1, which connects it to the internet. And we have a HyperCache client, which allows us to serve cached content to the subscriber. Each of these virtual networks is then controlled by an application running on top of ONOS. And we have another application which interconnects two virtual networks. On one side, it's connected to the HyperCache network, which allows us to serve content to the subscriber. And on the other side, it's connected to the internet, where we can prime the cache with content. So now let's dig deeper into the VCPE, where we can see the chaining of a virtual CPE and all the services. Again, this is quite a complicated view, and therefore we're going to schematize it on a slide. So here we have the chain of events for a subscriber, where we have an iPad, which is the model for a home subscriber. And when that guy comes up, he authenticates against the network. That gives us the set of services he has, which might be IPTV or an internet connection at a certain rate, and we provision the network with this information. We then spin up a virtual CPE, and we allocate a virtual CPE with a routable IP address that allows them to go out onto the internet. This area here gives us a layer of indirection where we can insert services dynamically. And that's pretty new and wonderful and exciting. So this is the hardware on which the core demo is deployed. We have a Netgear router, again flash with OpenWRT, connected to this entire setup. And here we have the access technologies. On the top we have Scipio, which is a G.fast DPU. And here we have a simplified OLT, which is also connected to this infrastructure. Again, these boxes are disaggregated and run OpenFlow to allow us to control them. And then we have a simple top-of-rack switch, which will be part of our fabric, which you'll see. And all this equipment is connected through this top-of-rack switch. Following that, we have our compute infrastructure, where we run all our services. This includes virtual CPE, parental controls, HyperCache, and all the other services that we need to run. So with that, we're able to connect a home user from his home and bring him into the central office and deploy services onto this hardware. So with that, this ends our demo, and this is the timeline. We architected and designed this demo in January, and we're hoping to move on with POCs, trial deployments, and hopefully larger scale deployments. Thank you.